Evening and welcome back to another session of uh, C++ programming. My name is Himanshu Gupta and today we'll cover runtime polymorphism. If you recall, in the last video we have covered the compile time polymorphism. Those who have not watched it, please go and watch it because it is a type of prerequisite. So basically we discussed that polymorphism means one name and multiple form. One name and multiple forms. We have discussed that polymorphism is of two types, compile time polymorphism and runtime polymorphism. We discussed compile time polymorphism, and under compile time polymorphism we discussed function overloading and operator overloading. Now in this video we will discuss runtime polymorphism. So basically if we define the runtime polymorphism, the runtime polymorphism occur when a function behavior is determined at runtime rather at the compile time, and this is achieved using the inheritance and virtual function. I will give a very simple example uh, to clarify what do we mean by uh, this. In these simple terms, what we do, we define a base class and define some virtual functions in it, and they call to this function we call the derived class version of these functions through the pointer of the base class, right? So let me explain you clearly using some example. Suppose we have a base class. This is our base class A, and it contains functions like show and display. Let's declare them virtual. I have already discussed in my last video that we can declare two types of virtual function. We have two type of virtual function and pure virtual function. Pure virtual function. If a class contains any virtual and a pure virtual function, one or more pure virtual function, that class cannot be instantiated, that we have discussed and see in the last video. If we simply write virtual with the function and give it some definition, it is declared as a virtual, but we need not to override it in the derived class. But if we declare a pure virtual function in the base class, then it becomes the responsibility of the derived class to implement the pure virtual function. If we do not give implementation of the pure virtual function in the derived class, then that class will also not be instantiated, right? So that we have already discussed. The pure virtual functions are declared like this. Suppose void show virtual void show is equal to 0, right? So this function does not have any definition and is called pure virtual function. And if a class contains any pure virtual function, that class cannot be instantiated, means we cannot create object of that class, and it is basically used to give some blueprint to the derived class, that this function has to be implemented by the derived class. So it gives some instruction to the derived class. Now what is uh, you know this runtime polymorphism? If we create two subclasses suppose B and C of this class A like this, and we override these functions show, display, and show display. What we will do, we'll create the base class pointer like this. You please note that this is our base class and it contains some virtual functions. It may contain pure virtual functions, so we cannot create object of this class. If this class contains pure virtual function, we cannot instantiate it, we cannot create object of this class, but we can create reference of it like this. We can create a pointer, and then let's create the object of the base class like this, B, and object of C. So runtime polymorphism say that the call to the overridden function is determined at the runtime. The call to the overridden function is determined at runtime based on the type of object. Our base class pointer is pointing to, right? This means that if this base class pointer stores the address of B class and we invoke show method, this will call derived class version of show, right? If I call display function, this will again call the derived class version, right? If we do not declare some function as virtual like this, I can have some concrete function here, like suppose void my show, and suppose we override this also in our base class, and we try to call the my show. In this case, in this particular case, base class version will be called. Why? Because we have not declared my show as virtual. I will demonstrate this practically also, don't worry. So in the same manner, if I assign the address of object C to the base class pointer OB and call show, now it will call show method of class C. Likewise, if I call OB display, again it will call display method of class C. Here we have to take care of one thing, that if this class, the derived class, if the derived class contains its unique method, some function particular to this class, like this. Suppose show C. So this function show C belongs to class C, and it is not derived from the base class, right? So if I try to access this show C function using the base class pointer, this will raise an error, right? Just a second. Okay, so this will raise an error. So I think theoretically I have explained you what is the runtime polymorphism. This is also known as dynamic binding or dynamic dispatch. See, when we call the methods like this, ob.show, this is known as static dispatch of method or static method dispatch. But here, what we are doing, we are trying to access the functions using the base class pointer like this, and this is known as dynamic dispatch. I have explained you this using this example. Runtime polymorphism in C++ is achieved using the inheritance and polymorphism. Sorry, inheritance and virtual function. So we declare some virtual function in the base class, and virtual functions basically gives blueprint for the derived class. That derived class has to give the implementation of the virtual function. We have two types of virtual function: pure virtual function and uh, normal virtual function. So virtual functions can have some definition, and in the derived class it is optional to override them. Means we can give our own implementation in the derived class or not. It is totally optional. But if we are declaring the pure virtual function like this, then it is mandatory for the derived class to override the pure virtual function to give its own definition. Then what we are doing, we have created a base pointer of base class like this. Here it is worth noting that we cannot create the object of this class. We cannot create the object of this class, as this class can contain maybe containing pure virtual function. Pure virtual function. We cannot create class, but we can create the reference like this, right? Then we have created objects of base class, and what we are doing, we are uh, assigning the address of base class, sorry, derived class to the base class. This is possible because there exists child parent type of relationship here. We cannot store the address of any other class in the base class. It is only possible when you are doing the inheritance, right? So using this pointer, we are accessing the overridden version of the derived class like this. So this call is determined at the runtime, and this is known as runtime polymorphism. So I think theoretically you have now understood what is runtime polymorphism, and now we will I will demonstrate you this using the our online compiler. So I have already opened the online compiler, and let's try to use the same example, right? class A. In class A, I will uh, declare three functions. Suppose void show. This is concrete method. I am not declaring it as virtual. Let's print a simple message here. Inside show method of base class. Right. Now create two more methods. Let me copy this. I'm calling it show one. Let's call it show one and declare it as virtual void show one. So this is a virtual function, and the third one I'm declaring a pure virtual function void show 2. Let's call this show 2 and 0. This is our pure virtual function. So as per the definition of uh, abstract class, if a class contains any pure virtual function, we cannot instantiate it. So we cannot create the object of class A. Now let's create two base class B, inherit class A here, public A, and so in the class B, see, the show method is the concrete method, so we need not to override it. But the show one method is also is a virtual function, but it contains some default definition. So it is optional to override it, right? But it is mandatory that we override the show to method like this. Void show to. Give some definition here. See out. Overriding virtual function show to. That's it. Actually, give override other two members also, other two methods also, like this. This is our show. Show one. Show one. So we have overridden all the three methods in the base class show one, and show two, like this. And I want to add one more method here, show 3, which is the exclusive method of class B. It is not inherited from the class A. I want to create one exclusive method of class B. Give some print statement here. Show 3 method of class B, right? Now let's copy paste this class and create another class C. This is our class C. This class is also inheriting class A, and here in the same way we are overriding all the three methods show 1 and show 2, and let's call this display, right? Display method of class C. Okay, now let's try to implement the runtime polymorphism. Create the reference of class A OB. Now object of B and object of C. Now what we'll do, we will assign address of object B to our reference, and let's call OB dot show OB dot show 1 and OB dot show 2. First let's call only these three methods and see what is the output. Let me check, there is some error. Oh, I'm sorry. Since this is the pointer, they will be invoked like this. Okay. So now what is the output? You can see inside show method of base class, overriding virtual function show 1, overriding virtual function show 2. So what we are observing, that show 1 and show 2, we are calling all the three methods using the reference, using the base class reference. But in case of show 1 and show 2, the overridden versions are being called. But in case of show, the base class version is called. This overridden version is not called. See, in the case of show, overridden version is not called. Rather, the base class version is called. And why this happened? Why this happened? This has happened because we have not declared our show method as virtual, right? So we are able to override only the virtual functions using this, right? Now let's try to access, this is one thing. Now let's try to access the exclusive member function of class B. These three functions are inherited from the class, from the parent class B, A. Now we will call show 3, which is the exclusive function of class B, and check whether we are able to call it using the base class reference or not. We are not able to call show 3, which is the exclusive function of derived class, right? So this is not allowed. So what is the concept? We can access only those members that are inherited from the parent class using the parent class reference, like this. Okay. Now what we will do, now assign the address of class C here, and somewhere write class C so that we will be able to differentiate class C. Class C. I am just writing class C here so that you will be able to differentiate that in previously we were calling the class B versions of function, and this time class C, and display method is the exclusive method of the class C, right? So now let's call all these functions like this. Okay, first call them. So you can see again the show method, which was not declared as virtual in the base class. Its base definition is called, and in case of show 1 and show 2, their derived class definition is called, right? If we try to call the display method, which is the exclusive function of class C, like this, this will not be permitted and it will throw error. We cannot access exclusive method of derived class using the base class pointer. So I think now you have understood what is runtime polymorphism and how we implement it. So thank you for your time. We'll see you in the next video uh, with some new topic. Please don't forget to subscribe and like my channel. Thank you.